Hey everyone, today we're going to be taking a look at section 4.4 in your textbook. We're going to be doing one aspect of it today, and specifically we're going to be finding the vertical asymptotes, and also the holes, call them just holes, of a rational function. A rational function is something that we've seen a lot recently. A rational function just means a fraction. Whenever you say the word rational, think fraction. So where are the vertical asymptotes of a function that is a fraction? That is generally when you will see vertical asymptotes when you have these rational functions. So the question is, how do we find those vertical asymptotes? And in this specific place, we're going to talk about algebraically, meaning we have no idea what the graph looks like. We're just going to look at the function and use algebra techniques to find the asymptotes. So first thing we need to do is define how we're going to do that. So for vertical asymptotes of this type of function, they're going to occur at the zeros of the denominator that are not also zeros of the numerator. So we're looking for numbers that make the bottom zero, in other words, make the function undefined, but also are not a zero of the numerator. If that is the case, it's a zero of both, then we have actually a hole. So a hole, we'll just call it a hole for now. The technical term for that is a removable discontinuity. A removable discontinuity, which if you take calculus, we'll talk about that. But for now, we'll just call it a hole. And that's where we have a zero of both numerator and denominator. That gives us a hole. In this section, we're not actually asked to identify the holes, but in the coming sections, we'll be asked to identify those holes. So it's a good idea on each of these to just go ahead and find the vertical asymptotes. If it's not a vertical asymptote, then it will be a hole, so we can just sort of identify both. All right, so with that being said, let's go ahead and begin. These vary in difficulty from very easy to a little bit more challenging. The only thing that really makes them challenging can be the factoring portion of it. So first thing that we always want to do is figure out the zeros of the denominator. I'll just go ahead and write this over here. So for the denominator, we're going to set the bottom equal to 0, 15x plus 9, and solve it. We get 15x equals negative 9. Go ahead and divide x equals negative 3/5. All right, so that is a candidate for a vertical asymptote. The only other thing we need to do is compare it to the numerator. So for the numerator, on the next one, I'll delete this other stuff, but for now, the numerator, we're going to set that equal to 0, x squared plus 9x plus 8, and solve it. To do that, we need to factor it because it's 3 terms. So we just need to think of what numbers multiply to give us 8 and add to give a 9. That is 1 and 8, so x plus 1, x plus 8. And then we would solve each of those. X plus 1 equals 0, so x equals negative 1. And x plus 8 equals 0, so x equals negative 8. All right, now these are not asymptotes. These are just used to check. These are used to check. Used to check. In other words, are these the same as this one that I found? If I did have an overlap, if they were the same, that would be a hole. But since there's not the same, this is a vertical asymptote at negative 3/5. That would be a vertical asymptote of this function. And if you were to graph it, you would see that you wouldn't necessarily see the vertical asymptote on the graph, but you would see that it would sort of, well, I guess I could just graph it really quick and show you. But feel free to check your work using these graphs. I would not recommend trying to locate them just using the graph on your calculator. That would not be a very successful endeavor. But it doesn't hurt to just check our work here. So this graph looks something like this. and then it goes like this. So you can see what's happening here is there is a vertical asymptote right here. And this is at -3/5. So that's the line x equals -3/5. The function goes up to positive infinity there, goes down to negative infinity here. That's called a vertical asymptote. Again, you won't actually see a dotted line on your calculator, but that's how we write them as we draw them with the dotted line. So we're just going to type in, there is one vertical asymptote, and that is at x equals, you do have to type in the x equals -3/5. All right, let's go ahead and clear out the rest of this stuff for our next question. All right, this should be another pretty straightforward one. So we need to find the zeros of the denominator first. I always just do that first. It doesn't matter the order, I guess, but the denominator, first of all, 3x minus 30 equals 0. It's a pretty straightforward one to solve. Add the 30 over and divide. So x is 10. So that is a candidate for a vertical asymptote. We're not going to label it as such yet until we compare with the numerator. Numerator is just used to sort of verify against the denominator. For the numerator, it's going to be pretty obvious that it's not going to be 10. It's 5x equals -4. Divide by 5, x is -4/5. So it's not 10, so it doesn't really matter. We don't really need that. This is a vertical asymptote. There at x equals 10. And in the same way, you could verify that if you looked at the graph of the function, you would see something like an asymptote there. All right, here's where we get into the hard ones. All right, let's start with the denominator. Here's where you got to bust out your factoring skills. When you set the denominator equal to 0, for this particular one, you always want to try to, when you see a number in front like this 2, the first thing that you would want to try to do is pull that 2 out. So see if every term has a 2. In this case, we're fortunate that is the case. So we pull a 2 out, and then we're left with x squared plus 7x plus 6. And that becomes far easier to factor. This 2, you could actually sort of divide it away at this point, but I'll just leave it hang out here. So then we need what multiplies to give you 6 and adds to give you 7. So that's 1 and 6. X plus 1, x plus 6, 0. Again, that 2 you can just kind of ignore because you can really just divide both sides by 2. 0 divided by 2 is just 0. So we said x plus 1 equal to 0 and x plus 6 equal to 0. And we get -1 and -6. So those are my two possibilities. One could be a vertical asymptote. One could be a hole. They could both be vertical asymptotes. They could both be holes. We got to figure the rest out. So in order to do that, we need to figure out the top there. All right, so in order to do that, we need to factor somehow 3x squared plus 25x plus 42 equals 0. That's for our numerator. See if those overlap at all. Now let's say you're not great at factoring that. This one is going to be a challenge because you cannot pull out a 3. 3 does not go into 25 evenly, so you could not pull out a 3. There's a number of ways you could do this. One way that I learned how to factor this and I've taught is you multiply this times this, 3 times 42. That's 126. And on the bottom, you write the b. So that's 25. So a times c on the top and then b on the bottom. You have to think of then what multiplies to give you 126 and adds to give you 25. That one might not be so easy either. We've got 2 and 63. That's not going to work. 126 divided by 3. 3 and 42, that won't work. 4 does not go into it. 5 does not. So let's try 126 divided by 6. 6 and 21 doesn't quite work. So let's try the next one. 7 and 18. That's going to be our magic numbers there. 7 and 18. They multiply to give you 126 and add to give you 25. So then what you do, if you've seen this before, this is like the grouping method of doing this. You then use these two to split this one. So we'll keep our other terms, 3x squared plus 7x plus 18x plus 42 equals 0. We then group it. In grouping, you draw a line down the middle. You pull out any GCF of each half. So here you can pull out an x, and you're left with 3x plus 7. On the other part over here, you want to pull out a GCF, which is going to be 6. So plus 6 times 3x plus 7. And what should happen is these always match. So then you pull the front ones together, gives you x plus 6, and you keep the back ones there. 3x plus 7 equals 0. And then you solve each of these, so you get x equals negative 6 and x equals negative 7/3. Now you'll notice this x equals 6 is one here, so that is not going to be a vertical asymptote. That is going to be a hole because it overlaps. This one, x equals negative 1, is good because it did not overlap, so it's going to be a vertical asymptote. So in future assignments, I believe you do have to identify the holes in some of them. So you would just write that x equals negative 6 as a hole, and then x equals negative 1 would be a vertical asymptote. All that's implying is if you look at the graph, I have no idea what this looks like, but let's just say at negative 1, there is a vertical asymptote, so it goes up there, or it goes down like that. And at negative 6, there's a little hole in the graph, and then just keeps going on. You won't be able to see that hole when you look at your graphing calculator because it's going to be so minuscule, and the pixels on a graphing calculator can't show you that, but there is a hole there. We obviously exaggerate a little bit. It's not that big, but there would be a hole there at negative 6. All right, and now I know the factoring is not a forte for some of you. It's always a struggle for some. So let's say you can't factor this top, but you still needed to confirm if one of these is a 0 at the top or the bottom. An alternative way you could do that, alternative check, is to plug these two zeros in. So if you just plug negative 1 into the top, 3 times negative 1 squared plus 25 times negative 1 plus 42, and see what you get. You do not get a 0. I don't know what you get, but you don't get 0. It looks like you get negative 3, negative 28. So that would be, I think, positive 14. Since positive 14 is not 0, then that means this one's good. If you plug in negative 6, 3 times negative 6 squared plus 25 times negative 6 plus 42, you evaluate that, you're going to end up getting 0. So since you get 0 when you plug in negative 6, that's a no-go. That means it's a hole, which is probably significantly easier than actually factoring the top. It's not always the case, but you don't really need to know the zeros of the top for this. You just need to know it if the bottom are zeros at the top. So another way you can do this is to just plug them into the top and see if you get 0. If you don't get 0, you're good. It's a vertical asymptote. If you do get 0, that means it's a hole. Okay, let's go ahead and type this in, and then we'll look at another scenario here. So we only got 1, even though there was 2 numbers we got for the bottom, only one of them is a vertical asymptote. That is x equals negative 1. All right, here's another situation. So we'll kind of repeat that, what I did on the last one. Let's clarify it if you're a little confused here. Also, just a reminder, you can always click on these watch help videos too. Maybe it explains something a little different if you're confused. So let's find the zeros of the denominator first. Those are possibilities. X squared minus 10x equals 0. This one, since it's only 2 terms, you're not going to do that 2 sets of parentheses. Whenever you see 2 terms, think GCF. So we pull out an x, and we're left with x minus 10. So then we have x equals 0, x minus 10 equals 0. So we get 0 and 10. Those are our 2 possibilities. Now, like before, the top looks a little bit difficult to factor. So what you could actually do, if you want to, is just plug these 2 in to the top. 3 times 0 squared plus 27 times 0 plus 54. I'm going to get 0 plus 54 is 54. So since that's not 0, that means that's good. It's a vertical asymptote. And then I plug in 10. 3 times 10 squared plus 27 times 10 plus 54. That's going to give me 300 plus 270 plus 54. That's not going to be 0 as well. So 570, 624, something like that. So that is not 0 as well. So that's going to be a check mark. That is a vertical asymptote as well. So that's the alternative way. You don't actually have to factor the top. You will need to be able to factor the top for later sections, but for this one, just find the vertical asymptotes. You don't actually have to factor the top, so that would be a shortcut. Now let's say you did want to go ahead and just find the zeros just to verify of the numerator. This one is also good to know how to factor. You will need to factor well for calculus. This one, it looks to me like you can pull out a 3. Yeah, because 54 is divisible by 3. So if you pull out a 3, it'll become x squared plus 9x plus 18, because 18 goes into 54 3 times. You then will get 3 times, you need two numbers that multiply to give you 18 and add to give you 9. That would be 3 and 6. So x plus 3, x plus 6. And when you solve those, you can divide by the 3 there. We get x plus 3 equals 0, so negative 3, and x is negative 6. And you can see, again, neither of those conflict with the denominator, so that verifies they're both good. So either way you can use to verify this works for this section. So choose whatever one's easier for you. Some of them it might be easier to factor, some of them it might be easier to plug in. So we're going to say this has 2 vertical asymptotes, x equals 0, and x equals 10. That's another, let's do one more, maybe a little bit more challenging one. This will be good. All right, let's go ahead and first find the zeros of the denominator. Easy part, very easy one to solve. We just get 3x is negative 18, so x is negative 6. So right off the bat here, since we only have one of these, I would definitely just plug this into the top and see if it's a 0 of the top as well. That will tell you if you don't get 0, then it's a vertical asymptote. If you do get 0, it's a whole. So let's just go ahead and do that. For our check in the numerator, you can still even just write out numerator, showing that you're checking. 5 times 6 squared minus 42 times 6 plus 49. Might require a little bit of work. Let's see. We get 186. Yes. 180 minus 240 and 252 plus 49. I don't think you're going to get 0. It looks like you would get 229 minus 252. So it would be like negative 23 or something like that. At any rate, you should not get 0, which says that, yes, this is a vertical asymptote. Just for good time's sake, if you wanted to try to factor this, which you should be able to factor this, let's go ahead and do that. Not the easiest thing to factor. You cannot pull out a 5. So there's a number of ways of doing this, depending on whatever you learned at your homeschool. Factoring this, one way is to multiply the a times the c. That's called the big X method. 5 times 49. Some people kind of do this, except they like flip it up, like divide and flip up. You can do that too. I think that might actually be easier. This is just the way that I learned it. You do a times c on the top, and then b on the bottom. And then you have to figure out what factors of that top can give you the bottom. Maybe not so easy on this one. 5 and 49 are possibilities. You could not get 42 with that, though. Let's try, let's say 245 divided by 3. That's not going to work. 245 divided by, let's say 7. 7 and 35, that seems like that's going to work. You could get 42 from that. So we would want them both be negative, negative 7 and negative 35. Because those add to give you negative 42. So then we split this one up, make this 5x squared minus 7x minus 35x plus 49 equals 0. We then divide it down the middle, pull out an x, so we're left with 5x minus 7 We know this 5x minus 7 has to match over here. We just got to figure out what pulls out, and that would be negative 7. So then we have x minus 7 when we pull the front two together, and 5x minus 7. So we get x equals 7 and x equals 7/5. So these would be the zeros in the numerator. Again, you can see they don't conflict with that negative 6, so that verifies that that's good. Obviously, that took a lot longer. You can do the plug-in method for this part. So that is it, guys. Do your best on those. And as always, be sure to reach out to me if you need help. Thanks.